wabarakatuh. My name is Nur Elisa Adwana binti Hisham and I'm going to be explaining about the project proponent for this project. So this project is initiated by the Berjaya Alam Manusia Berhad, which also known as BAM. So here I also include the logo of the project proponent, the address and along with the telephone and facsimile number and the person to whom inquiries regarding the EIA.
Hi, Assalamualaikum. My name is Nur Afifah Fakihah binti Zaki. So today I would like to present my point, which is the list of consultants, existing of environments and mitigations and abatement measures. So in this EIA study, it was carried out by AMR Environmental Sdn Bhd, which is led by IR Amar Rashid, who is a managing director in AMR Environmental Sdn Bhd. IR Amar bin Muhammad Rashid was graduated in civil engineering from the University Technology Malaysia. The DOE registration number is C0908 and the experience is Managing Director of AMR Environmental Sdn Bhd, CEO of AMR Edu Hub Sdn Bhd, a Director of AMR AZ Brunei Sdn Bhd, and lastly is a co-founder of Amora Nur.
Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Muhammad Syukir bin Rashid and I'm going to explain for the statement of need for this proposed project. So the objective of this proposed project is to develop the Sustainable Scheduled Waste Treatment Center, which is SSWTC, due to the shortage of scheduled waste treatment and disposal facility in Malaysia. Next, to expand its service to consider handling all 76 out of the 77 types of scheduled waste code, which as listed in the first schedule of environmental quality schedule under Schedule Waste Regulation 2005. And lastly is to enhance and promote the 4R cradle to cradle approach by utilizing the existing DTSL resources in the establishment of SSWTC. So the key statement of that is needed for this project is to provide service of scheduled waste treatment and disposal facility for the waste generator in the whole Malaysia. Next, to reduce illegal waste dumping that cause environmental pollution. Next is to ensure disposal of industrial waste conducted systematically. Next, to provide effective service and technology for scheduled waste treatment. And to reduce carbon footprint by minimizing transportation distance of waste generator to SSWTC. Next is to ensure the packaging, labeling, and storage of the scheduled waste conducted systematically. Then it's also to adopt environmental conservation and sustainability. And lastly is to improve the employment and economic opportunities for local population.
The development of Sustainable Scheduled Waste Treatment Center SSWTC proposed site is located at PT 1382 Bukit Tagar Sanitary Landfill, Mekin, Sungai Tinggi, District of Hulu Selangor, Selangor Direct Asan, with GPS coordinates of latitude and longitude is mentioned in this slide. The aim of the proposed project is in response to the shortage of scheduled waste treatment and disposal facilities in Malaysia. The proposed project will occupy 40-acre land within the BTSL, which occupy in landfill footprint of 700 acre with another 1,000 acre of buffer zone along its boundary. There are several facilities currently in operation within BTSL premises as leachate treatment plant, for sanitary landfill, Emita, Kap Berjaya Kita, AKBK and Renewable Energy Centre. The proposed site will consist of Labadu TE thermal treatment plant and secure landfill as well as other supporting facilities such as storage facilities, solidification facilities, oil recovery facilities, leachate treatment plant, and surface water treatment plant. The location of the proposed site and the existing facility available within the BTSL boundary. The state-of-the-art sanitary landfill, leachate treatment plant, and a 10 megawatt landfill gas-to-energy plant are located to the west of the SSWTC project site. The LTP is equipped with advanced supervisory control and data acquisition (SCADA) system for continuous 24-hour active monitoring of the facility. Similarly, Sustainable Resource Centre of Scheduled Waste Recycling Facility Amita Berjaya Kita (AKBK) is located to the southwest side of the project site. AKBK recycle a total of 15 code of scheduled waste under the Environmental Quality Scheduled Waste Regulation 2005. This is the layout plan of the proposed project. As you can see, the red line area is the facilities involved in this project. SWTC provide the transportation for collecting scheduled waste from the waste generator. The waste will be transported by BAM licensed and registered vehicle with the Department of Environment. Upon arrival at the facilities, the scheduled waste is weighed, stored, inspected, and analyzed before it is being treated or disposed accordingly. The scheduled waste is assigned to the appropriate treatment and disposal facility based on the waste acceptance criteria (WAC) that takes into account of waste analysis and waste form. The WTE thermal treatment process also generates its own waste that need to be further treated at the other supporting facilities. For an example, bottom ash generated from the WTE thermal treatment plant is generally being disposed directly into secure landfill due to its inert characteristic, while fly ash with high heavy metal content is treated at the solidification facility before being disposed into the secure landfill.
As for the project option, there will be three options that needs to be initiated in this project. So the first one is site option, the second one is technology option, and also the third one is no project option. So for the site option, in generally, there are four objectives that need to be achieved in this selection of suitable site. So the first objective is minimize health risk, minimize environmental impact, maximize public acceptability, and also minimize cost. In addition, the criteria for the site selection for implementation of proposed project have considered as land use compatibility, logistic requirement, infrastructure needs, buffer requirement, and also development and socio-economy. So for the technology option, this project has selected the WTE thermal treatment. So generally, the WTE thermal treatment is widely used as a process to eliminate hazardous material efficiently and viably option to safely treat toxic chemicals. So WTE thermal treatment system of waste can be divided into combustion, gasification, pyrolysis, plasma, and also co-combustion. So for the no projection is not acceptable long-term solution, and an alternative schedule waste treatment and disposal site must be identified for the sake of the future schedule waste management in Peninsular Malaysia. An integrated schedule waste management facility should be sought as an alternative and to complement the existing facility available in the country.
We move on to the existing environment part. In this part, it contains 5 topics that need to be discussed. The first one is physical environments. In physical environments, there are 3 categories, which is geology, hydrology, and river system. In geology, it characterized by a recent alluvial deposit and pre-quaternary bedrock. Next is, this project is proposed under link with the arenaceous rock comprising metaquartzite, metatine, stone grit and siltstone with the few bands of cis and phyllite. The rock is folded and inclined between 20° and 45° with particle size ranging from 2 to 0.06 mm or 0.04 millimeter if silt is included. For the hydrology, it contains of 4 elements, which is the first one is sand, next is clay and silt, next is peat, humid, clay and silt, and lastly is clay, silt, sand and gravels. For the river system, the proposed site is within the Sungai Nyamuk Basin with the area of 1,529 hectares. Sungai Nyamuk is a small stream that flows in north to south directions that located southwest of the project site. The Sungai Nyamuk eventually flow into the Sungai Air Hitam and into Sungai Selangor, located much further to the south. Next is climate. Climate contains 3 categories, which is existing meteorological information, rainfall and temperature, and surface wind. For the existing meteorology information, these areas are warm and humid conditions with the sunshine all the year round. Northeast and southwest monsoon occur during the months of November to March and May to September. For the rainfall and temperature, the total average of annual rainfall is around 2,945.42 mm with a range from 2,567.8 mm in 2004 to 3,535.4 mm in 2018. The annual temperature range from the 24.8 Celsius to 33.1 Celsius. And lastly is surface wind. The most frequent occurrence of wind speed is at 0.3 to 1.5 meter per second, while the second frequent at 1.6 to 3.3 meter per second. So next is the health survey. From the survey, and the asthma is the most common chronic among the children with the percentage of 1.8%, while the adult is 0.4%, which is acute asthma. Next is hypertension and diabetes are most common among the adult, which is 8%, and the children is 5.7%. And there is no cases of lung cancer, and the prevalence of infectious disease is very low, which is less than 0.5%. And also there is no cases of dengue reported. Next is 0.8 of the adult presented with a productive cough, while the children is 0.9%. Lastly is some of the children and adults have a fever with 1.8% and 4.6%. For social impact assessment, 65% agree on the purpose of SSWTC development from the 79 respondents. The respondents are agreed because this project can increase the job opportunities to the community and also help to reduce the unemployment rate among the villagers. And it also improves the infrastructure and increase the community socio-economic and developments of local economy. For environmental monitoring, there are 5 categories that we need to monitoring. The first one is air quality. The result of air quality were compared to the Malaysian Ambient Air Quality Standard 2050, and the air quality also observed with the allowable standard limits by the DOE. And the parameter is PM10, PM2.5, CO2, SO2, and NO2. Next is water quality. It observed by the allowable standard from the water quality index, and the parameter is DO, COD, BOD, TSS, pH, and ammonia nitrogen. Next is groundwater quality. And the result of groundwater quality will be compared to the standard quality air tanah kebangsaan. And the parameter that will be measured is pH, iron, E. coli, TDS, sulfate, nitrate nitrogens, and phenol. So next is noise quality. Noise quality will be measured using the sound level measurement, and the result will be compared with the designated permissible sound level. Lastly is odor quality. The odor quality is classified as natural earthy, where the DT detected is less than 2.0.
Okay, next we focus on the baseline information. So there are several baseline information for this proposed project. Okay, number one is the ambient air quality. So this the ambient air quality will be compared with the Malaysian Ambient Air Quality Standard 2015. So the parameter that were studied is PM10, PM2.5, carbon monoxide CO, SO2, and O2, and also O3. So for PM10 and PM2.5, CO, SO2, and NO2 are recorded below the permissible limit, while O3 is not detectable at the area. So next, we move on to the water quality. So we will use comparison with water quality index from the National Water Quality Standard. So the parameter that was studied is dissolved oxygen, chemical oxygen demand, biological oxygen demand, total suspended solid, ammoniacal nitrogen, and pH. So the location for this study is at the Sungai Nyamok, Sungai Air Hitam, and Sungai Selangor. So we can see that table is the water quality index result. So based on the 5 location, so two out of the 5 location, which is W2 and W4, is category as clean, while W1, W3, and W5 is category as slightly polluted. Okay, next we move on to the groundwater quality. So for the groundwater quality, we will have 4 monitoring stations, which is GW2, GW10, BHA, and BHB. So we will compare it with the standard quality air tanah kebangsaan, and this is done in order to determine the impact of possible seepage from the SSWTC to the underground. So we can see based on the result, we can see that the overall inlet is in under category clean for all 4 monitoring stations, and the parameter that was studied is pH, iron, coli, total dissolved oxygen, total dissolved solids, sulfate, nitrate, nitrogen, and phenol. Okay, next the noise quality monitoring. So the method is we will measure for 24 period hour monitoring, and we will conduct it for 2 periods, which is during the day and also the night. So there are 2 monitoring stations, which is inside the proposed project, which is N1, and also at the sensitive receptor, which is at the village N2. So the result is we can see that N2 has lower noise level compared than the permissible limit, while for N1 it has higher noise level than permissible limit. And the equipment used is the sound level meter. And lastly is the odor quality monitoring. So based on the study, we can classify that it is as natural earthy, which is the detected level is below 2.0, where we can conclude that it is acceptable under slightly noticeable.
The project location and existing land use. The main land use of the Hulu Selangor district in 2008 is the forest land located at the eastern part with border Pahang state with 53%, followed by the agriculture area that make up 14.7% of the area. The picture in the screen shows the current land use map of Hulu Selangor district in 2008. The next picture in the screen shows the proposed land use map for Hulu Selangor district in 2020. Under Hulu Selangor District Local Plan 2020, the project site is demarcated for infrastructure and utilities purpose. The surrounding area of BTSL will remain as agriculture with this oil palm with the 500 meter buffer zone. The proposed project site is located within the lower area in between 5 meter to 150 meter from the sea level, accordingly to the study prepared in Hulu Selangor District Local Plan 2020. The location of proposed project site is strategic as it has 500-meter buffer zone surrounding the existing BTSL site. The buffer zone will act as a shield, minimize the environmental impact that may occur, if any, during construction and operation stage of the proposed project toward the surrounding sensitive receptor. Other than that, there are no sensitive receptors located within 2 km radius from the project site. The picture shown in the screen is about 5 km radius map for sensitive receptor from the proposed SS WTC boundary. So there are 7 building or facility involved within 5 km radius map. Slide show the distance of sensitive receptor area which involve around 2 km until 3 km involve the Kampung Sepakat, settlement of Nigel Gardner Estate, settlement of Mary Estate, Sekolah Jenis Kebangsaan Tamil Ladang Mary, Sekolah Jenis Kebangsaan Tamil Nigel Gardner. However, the distance of sensitive receptor area for 4 km until 5 km involve 2 settlements, which is the settlement of Bukit Tagak Estate and settlement of Minyak Estate.
So for this slide is the potential significant impact. So the first one is the air quality impact assessment, which is it is uncontrolled condition where the air is released without going through the air pollution control system. So the impact are particulates, heavy metals, gases, acid gases, which is hydrogen chloride and also hydrogen fluoride, and also dioxin furan to the surrounding area were evaluated and assessed in this assessment. Next is waste management. So the potential waste will be generated during the construction and operation phase from this project can be divided into two, which is solid waste and also scheduled waste. So the solid waste mainly came from the domestic waste and construction waste. This waste shall be properly stored in the design place to be disposed. So for the solid waste, it will be disposed in BTSL. For the wastewater quality, so the contaminant leachate that generated from the secure landfill cell will be channeled to the leachate treatment plant for the removal of organic matter such as BOD, COD, and also suspended solid, including heavy metals and also ammonium nitrogen. Next is health impact assessment, which is employ the environmental health risk assessment (EHRA) to approaches in estimating the likelihood of potential adverse effect from the exposure to the environmental hazard. For the water quality assessment, the potential impact that might occur is that when the effluent from the leachate treatment plant reaches the nearby river. And as for the groundwater quality, the groundwater study is need to be conducted in this project to determine the potential changes in the groundwater regime due to the development and operation of the facility. So for the next slide is also the continuous from the potential significant impact. So for the land farming disturbing, it divided into three, which is the existing, that is before construction, disturbed and uncontrolled during the construction and no application of ESCP. And the third one is disturbed and controlled during the construction and with the application of application of ESCP. So the next one is social impact assessment. There are several potential impact that has been identified and could impair the surrounding environment and impacting the community health, including the noise annoyance from the transport vehicle, unpleasant smell from the scheduled waste, water pollution, and also dust emission. As for the odor quality, it will produce unpleasant smell from the scheduled waste. So it is preserved that potential odor mainly sourced from the smell of the raw leachate at the leachate treatment plant. So two potential specific sources were observed to potentially causes the odor, for example, equalization tank and also a nitrification tank. The next one is quantitative risk assessment. So the major accident that may occur during the operation phase of this project with the potential for personal injury or fatality includes fire, explosion, and also release of the dangerous substances from the scheduled waste is also considered as event for the future evaluation. And last but not least is the noise quality that needs to be measured by using sound level meter to establish the existing background noise level at the project site that is also affected the residential and sensitive area.
We move on to the mitigations and abatement measure. In this project, there are 9 adverse impact that will be measured. These mitigation measures are for the potential adverse of impact that resulting from the development of SSWTC. Although some of the potential negative impact may not have a serious impact to the environment, the mitigation measures are still necessary to be implemented in ensuring the effect derived from the implementations of the proposed project would be either minimized or eliminated. The mitigation measure designed in 3 phases, which is construction phase, and operation phase. So this is the mitigation measure for the air quality, health impact, land disturbance, waste management, water quality, groundwater quality, quantitative risk assessment, noise quality, odor quality.
Okay, moving on. We are going to explain about the residual impact. So, residual impact is the impact that is we can get for in long-term condition, which is for around maybe 20 to 30 years. So there are 4 impacts that can be seen. So which is odor pollution, groundwater pollution, health risk, and noise pollution. So firstly is the odor pollution. So in long term, the odor pollution is maybe due to the sticking of the waste will arise. So another odor pollution is also from the transportation of the waste. Okay, next is the health risk. So some of the waste that are being thrown may not cause immediate effect upon contact, which they will cause effect that maybe take around 5 to 10 years to be seen, such as cancer. Okay, next is the groundwater pollution. So the leachate penetration may also occur in long term, maybe due to the linen cover of the landfill or the disposal site may no longer able to prevent the leachate penetration, maybe due to the corrosion or due to the long nearing expiry date. And also the lastly is the noise pollution. So this noise pollution may come from the transportation of the waste, which is very impossible to be prevented because the waste need to be transported, but it can be minimized.
On to the environmental management plan is the recommended to be outlined in order to manage all the potential issues identified in the report. EMP is a practical tool for the implementation of mitigation and protective measures identified in the EIA. For the performance monitoring, is a protective and preventive monitoring of process to ensure air pollution control system APCS as well as leachate treatment plant LTP are optimally operated and maintained during their operation phase. For the performance monitoring of air pollution control system is to abate the release of air contaminant into the atmosphere, and also a prerequisite of an uninterrupted and efficient operation of the control system. For the performance monitoring of leachate treatment plant is the leachate generation from secure landfill varies significantly in its characteristic. Hence, different unit process and unit operation are utilized to treat them. For the emergency response plan, an essential component of a facility safety and loss strategy, provide an organized structure for a chain of action to be put into motion in the event of emergency at the site. While environmental auditing is the audit report will be submitted on the annual basis to the DOE during the construction and operation stage to evaluate the degree of compliance with the regulatory environmental requirement. Impact monitoring is performance to monitor the impact of the emission and effluent discharge from the proposed project towards the nearby sensitive receptor. Last but not least is the compliance monitoring is conducted to ensure the emission and discharge from the proposed project comply with the local regulation and relevant standard during construction phase and during operation phase. There are 4 monitoring components involved during construction phase, and as you can see in this table, the monitoring component is ambient air quality, slip trap, discharge quality, river water quality, and noise quality. Moreover, during operation phase, the monitoring component involved is tap emission quality, ambient air quality, river water quality, groundwater quality, noise quality, and effluent quality. That's all from me. Thank you.